Hi class, we're gonna begin the next rule, the quotient rule in this video. We're gonna introduce it and we're gonna work on an example. The quotient rule can be generated also by using the limit definition, by having a quotient of two between two functions. So just like in 2.1 we did the limit definition, you could generate this formula just the same way. Of course, we're not going to do that in this video or in this class, but I just want to point that out. The So let's define the quotient rule. So of course this rule applies whenever you're dealing with a division of two functions. We're assuming here that f and g are two differentiable functions of x. So if we're looking for the derivative of the quotient, the division of f over g, then the derivative of this will be the difference, right, between the product of the the top function, the derivative of the top function, times the bottom left alone, minus the top left alone times the derivative of the bottom one, and then divide the entire thing, right? Divide the whole thing by the bottom function square. If you think about this is very consistent the way we wrote the product rule. If you remember, the product rule was something like this: f prime times g plus f times g prime, right? So it's almost the same, right? It's almost the same if you notice, except in this case this is plus and this is minus. Now in the first one the order doesn't matter, as long as you end up getting as long as you alternate the derivative between the two functions and you add them together. Here the order does matter. The first product needs to be the top function needs to be the derivative. The top function needs to be a derivative, and then multiply by the bottom function left alone. Minus, right, now the top one is left alone, in the bottom derivative, the derivative of the function of the bottom is being multiplied, right? So the order does matter. Order, let's write a note here. Order matters here, right? So be careful with that. All right, so the way we can read this is by saying the numerator of the result resembles the product rule, but there is a minus instead of the plus. The minus sign goes with the g prime, right? With the g prime. The denominator is simply the square of the original denominator. No derivatives there, right? Here is a nice way to remember it. U over v, the derivative of the quotient, u over v prime. U prime times v minus u, v prime over v square. Also, just like we did before, a big warning here. Common mistake is for students to do this, right? This is a big no, right? Let's not do that. That's a mistake. We have a special rule for quotient. Why students do this? Because they think they get confused with the plus and the with the minus rule, right? The plus and the minus rule does allow you to do that, right? So we gotta be careful with that. So please remember that from previous. So in fact, actually, I have it here, right? It's here. The plus. It's right here, right? It is true for the plus and minus. You just have to do the derivative of each one individually, but it does not follow for the for the derivative of a quotient. All right, so let's try example 5. So in example 5, you notice we have 4 minus x squared and over 5 plus x squared. So here clearly the quotient is this over this, right? So we recognize the top function is u and the bottom function is v. So we're following this formula, right? So what I end up doing, and I encourage you guys to do, is to try to set up this before you apply the derivative. So what I'm saying here is the derivative of this will be the top function, the derivative of the top function times the bottom one left alone minus the top function left alone times the derivative of the bottom function. And then no derivative for the bottom, you just square it, right, for the bottom. This is the actual derivative. All we gotta do now is go ahead and execute those two, meaning take the derivative of those two and follow, and then carry everything else. So the derivative of 4 minus x squared, the derivative of 4 is 0. The derivative of negative x squared is negative 2x times 5 plus x squared minus 4 minus x squared times the derivative of 5 plus x squared. The derivative of 5 is 0 plus the derivative of x squared is 2x. And then so this is it. That's your derivative, and at this point that's how we're gonna leave it. We can just write it as negative 2x times 5 plus x squared minus 2x times 4 minus x squared. So what I did there is I just put this in the front and I dropped these parentheses, right? And divided by 5 plus x squared over 2. And that's your derivative. And there you go. So I hope you guys find this helpful.